Welcome to the deep dive. Today, we're jumping right into something absolutely critical, really foundational to almost everything you do online, application programming interfaces,
Mm.
APIs.
Mm-hmm.
Our goal here is, well, to give you a really clear, actionable shortcut to understanding three of the big ones: REST, GraphQL, and gRPC.
Right. We want to cut through the jargon, look at what they are, why they exist, and, what choices they represent when you're building things.
Exactly. This isn't just theory. It's about understanding the architectural decisions that make your favorite apps actually work.
That's it. So for anyone who's, already working in tech or interested in it, this isn't API 101. We're really comparing these three: REST, GraphQL, gRPC. We'll look at their core ideas, the trade-offs involved.
And where they fit best.
Precisely. So you'll walk away understanding why you might pick one over the other and how that choice impacts, well, everything from performance to how easy it is for developers to work with.
Okay, so let's start with the basic why. Why different styles? APIs, at their heart, are just ways for software parts to talk to each other.
Yeah, like messengers.
But just like people communicate differently depending on the situation, software needs different ways too. Sometimes it's a simple request.
Give me this thing.
Exactly. Other times it's more complex, like, give me this specific bit of info about that user and that specific detail about their last order.
And sometimes it needs to be super, super fast, like internal chatter where every millisecond counts.
So these different needs, they naturally led to different ways of designing these conversations, these API styles.
Makes sense.
Okay, let's unpack the first one, REST. Often seen as the standard, maybe the baseline.
Yeah, definitely the most ubiquitous for a long time, especially for web services. REST stands for representational state transfer, but what it really means is it's about resources.
Resources like items or data.
Exactly. Think of it as giving addresses, URLs, to specific pieces of information or collections of information, like users 123 or products.
And how does it actually work? Like, what's it doing under the hood?
Well, it cleverly uses the standard tools of the web, HTTP methods. So get to retrieve data, post query to create new data, PT to update, delete to remove.
CR root operations. Create, read, update, delete.
Precisely. Match directly to HTTP verbs. And a really key aspect is that it's generally stateless.
Stateless, meaning...
Meaning each request from the client has to contain all the information the server needs to understand it. The server doesn't need to remember past requests from that client.
Okay, I see. And that helps with scaling things up.
Hugely. Makes it easier to distribute requests, easier to cache information using standard web caches. And the data format is almost always JSON, sent over standard HTTP. Very web-friendly.
Right. So an example might be an online store.
Yeah.
Like Amazon.
Perfect example. Your browser or app might ask for orders to get your order history, or maybe POs to cart to add something. Simple, direct requests for specific resources.
The pros seem clear then. It's straightforward, easy to get started with.
Definitely. Simple APIs, uses standard web tech everyone knows, works everywhere, scales well because it's stateless. Lots to like.
But there's always a but.
Yeah. The but is that this resource-based approach can be inefficient sometimes. It often leads to what we call overfetching or underfetching.
Okay, explain those.
Sure. Overfetching is when you ask for a resource, like users 123, but you only actually needed the user's name. REST might send you their whole profile address, phone number, everything. Too much data.
Wasted bandwidth, slower for the client.
Exactly. And underfetching is the opposite problem. Maybe your app screen needs data from users 123 and their last three orders from orders.userid123 and their profile picture from images profile 123.jpg.
So you have to make multiple separate requests to get all the bits you need.
Right. Multiple round trips between the client and server. That adds latency, especially on mobile networks. And this inefficiency, this client-side pain, is really what opened the door for other approaches.
Which brings us nicely to GraphQL. This came out of Facebook, right? Trying to solve exactly those mobile app problems.
That's the origin story, yes. They needed something more efficient for their complex mobile app UIs. If REST is like, give me this resource, GraphQL is more like, give me exactly these pieces of data I'm asking for.
So it shifts the power, in a way, from the server dictating the resource shape to the client specifying its exact needs.
Precisely. The client sends a query. It's not hitting different URLs for different resources. It usually talks to a single endpoint.
One endpoint for everything.
Typically, yes. And in that query, the client specifies exactly which fields it wants, even across related objects. It's like ordering a la carte, down to the specific ingredients.
How does the server know what's allowed, what data exists?
Through a schema. GraphQL APIs have a strongly typed schema that defines all the data that can be queried and the relationships between data types. It's a contract.
Okay, so the client queries against this schema, and the data format, still JSON.
Yes, typically JSON over HTTP, just like REST in that regard. But the structure of the JSON response mirrors the structure of the query the client sent. You ask for A, B, and nested C, you get back A, B, and nested C.
So back to that social media app example. Instead of hitting posts, then comments.postID, then likes.commentID, you could just...
Send one GraphQL query asking for posts, and for each post, it's comments, and for each comment, it's likes, all in one go.
Wow. Okay, that sounds incredibly efficient for the front end. Fewer requests, less data wrangling on the client, ideal for complex UIs.
Absolutely. It's a huge win for front-end developers dealing with complex data needs, faster apps, smoother development for certain kinds of UIs.
But again, the trade-offs. If the client can ask for anything, doesn't that put a lot of pressure on the back end?
It certainly can. That's the main con. This flexibility is powerful, but you really need to think about performance and security on the server side. Well, clients could potentially craft incredibly complex queries, maybe deeply nested ones, that could overload your database or back-end services. Think like asking for a user, their friends, their posts, you see.
Right, it could spiral. So you need protection, rate limiting, query depth analysis.
Exactly. You need careful implementation, potentially things like query cost analysis, depth limiting, maybe persisted queries to prevent malicious or just accidentally resource-intensive requests. Security is also different. You're not just locking down endpoints, but parts of the data graph. It needs extra care.
Okay, so REST for simplicity and standard resources, GraphQL for client flexibility and complex data needs. What about pure raw speed, especially inside a system between microservices?
Ah, now you're talking gRPC territory. Think of gRPC as the speed demon of the group. It's designed for high-performance, low-latency communication, primarily between internal services.
Not typically for browser-to-server communication, then.
Generally not directly, no. It's really optimized for server-to-server. It's a remote procedure call framework, RPC.
RPC, so calling functions on another machine as if they were local.
That's the core idea, yes. It tries to abstract away the network. You define a service with methods, and one service can call methods on another service across the network. gRPC handles the underlying communication.
And it's built on newer tech.
Right. It uses HTTP2, which is much more efficient than HTTP 1.1 used by many REST APIs. HTTP2 allows things like multiplexing, sending multiple requests and responses over a single connection concurrently, and server push. Big performance gains there.
But the really big difference is the data format, isn't it? It's not text-based like JSON.
Correct. This is crucial. gRPC uses binary data formats, most commonly protocol buffers or protobuf.
Protobuf, okay. What's the advantage there to smaller size?
Smaller size is part of it, yes. Binary is much more compact than text like JSON, but it's also about the contract and efficiency of processing.
How so?
With protobuf, you define your data structures, your messages in a separate .proto file. This is your interface definition language, or IDL. You then compile this definition for your specific programming languages.
Compile it. Yeah.
It generates code for serializing and deserializing your data structures very, very efficiently. It's strongly typed, and that contract is enforced at compile time, catching errors early. Much faster to parse than JSON too.
Okay, so it's fast, efficient, and gives you strong contracts between services. Where would we see this used?
Think large-scale microservice architectures. Like Netflix is a famous example. They have hundreds, maybe thousands of back-end services handling everything from user accounts to recommendations to streaming licenses.
And they need to talk to each other incredibly quickly.
Exactly. Milliseconds matter. So gRPC is perfect for that internal high-throughput communication. The pros are clear. Super fast, low latency, efficient, strong contracts, good for polyglot environments where services are written in different languages.
Sounds amazing for backend. What are the downsides then? Why not use it everywhere?
Well, that binary format and reliance on HTTP2 makes it tricky to use directly from a web browser. Browsers don't natively speak protobuf or easily handle the gRPC protocol without helper libraries or proxies like gRPC Web.
So, more setup needed for web apps.
Yeah.
And debugging.
Debugging can be harder, yeah. You can't just pop open your browser's developer tools and see plain text JSON going back and forth. You need specific tooling to inspect the binary protobuf messages.
Okay, so it's specialized,
Mm-hmm.
powerful, but for a specific job, high-performance internal communication.
Precisely. It's not really intended as a replacement for REST for general-purpose public web APIs. It shines in its niche.
Right. So connecting all these dots,
Yeah.
it really feels like there's a clear place for each. REST is still your go-to workhorse for simple resource access, public APIs, where that statelessness and web standard compatibility are key.
Absolutely. Simple, reliable, well understood.
Then GraphQL comes in when the client, maybe a complex web app or mobile app, needs more control. When it needs to fetch very specific, potentially nested data structures without making tons of requests or getting back way too much info.
Right. Solving that over-underfetching problem, giving power to the client, but with added server considerations.
And finally, gRPC is the specialized tool for when you need maximum performance and efficiency between your internal backend services. Low latency, strong contracts, but less suited for direct browser interaction.
That sums it up really well. It's not about which one is best overall, it's about the context. What problem are you solving? Who is talking to whom? What are the performance needs? The answer dictates the right tool.
Understanding those trade-offs is key, isn't it?
It's everything. Choosing the right API paradigm is a fundamental architectural decision with long-lasting impact.
Well, there you have it. We've taken a deep dive into REST, GraphQL, and gRPC. Hopefully you now have a much clearer picture of not just what they are, but why they exist, the problems they solve, and when you might choose one over the others.
You've got the shortcuts to understanding these core building blocks of the modern web and backend systems.
It really helps frame how complex digital experiences are put together behind the scenes.
Absolutely. And maybe a final thought to leave you with. Next time you use an app, whether it's ordering food, streaming a movie, or checking your bank balance, think about what might be happening underneath. Could it be REST fetching simple data, GraphQL assembling a complex view just for you, or maybe lightning-fast gRPC calls coordinating things deep in the backend? How do those hidden choices impact the speed, the features, the whole feel of the app you're using? What else might depend on these API strategies that maybe you hadn't considered before?